Hi everyone. We're just about to get into objects into actual C++ code. So we're actually going to get into object-oriented programming finally. Now we've done a big review of 1400. If you were bored, I apologize, but most times it seems that every time I try to cut a corner or make it go faster, people go, "Oh my God, I still don't remember pointers," and you might still have trouble with pointers now. So I want to make sure everyone's feeling comfortable. If you're still not comfortable about a topic, please either ask or just do more examples if you wanted to work on your own. So we're going to talk about objects soon, and this might not seem like that important of a thing. What's so special about these whole objects thing? But before we get into that, so we're going to look at the basics of basic features of C++, some of the new syntax that we have that we didn't have before. We're going to look at strings. We're going to look at cin and cout, which we didn't look at before. Uh, but the idea of an object, so because I want to repeatedly expose you to the idea, is that you wrap up data and code, so the functions and the data, they're wrapped up together and called an object. That's the concept. So you take your data, so like a struct is a bunch of data, right? You would put the functions that are associated with that struct with that data. You wrap them up together, and that is an object. That's it. But that changes everything on how you think about your code. That's why it's so powerful. Or at least it's more intuitive for me and for a lot of other people. Uh, and when you design programs like this, then you need to design your class structures and how your classes talk to one another. And that in itself is a different art form. And we'll be looking a little bit at that. But before we get going, we need to make sure we're going to review or look at strings, the string class. And we're going to look at cin and cout. I'd also like to point out before we dive into it, let's point out what we just looked at with linked lists. When we were talking about linked lists last time, so if you didn't watch the video, definitely watch that video, just because linked lists are going to be important for what we are going to be discussing for the rest of the term. We built some kind of structure to store the kind of linked list data that we're dealing with. We had a node, linked list node data structure. We had linked list data structure just to cover up the fact that we're storing just an integer. It could be a string, it could be whatever. It's just some kind of data being stored in the linked list. We had a linked list itself structure that we had. And then we made a whole lot of different functions. And the question is, why don't we just have the linked list know how to deal with itself? Which is a weird concept to say, but imagine if the linked list was intelligent, right? And knew how to deal with itself. So you said, hey, linked list, add this element, and it goes, sure, and it adds the element to it. Now, you still would have to write the code, but imagine if you thought of it as the linked list knows how to put elements in itself. Not you were adding something to this weird data structure, but the data structure knows how to deal with itself. That's what an object is all about. That's what we're going to be getting to. I find it's a much more of a intuitive approach to programming, but you might disagree. Okay, so we'll do a quick detour on cout, cins, and strings. I've already done the outlines of how this is actually going to work because I didn't want to delete it all over again, but uh, and we'll have a bunch of sample code that we're going to work through. So here is a string like hello world. This, notice, is a brand new word we didn't have before. We had C strings before. This is brand new word where it is I don't know why my pen's not working here. I'm going to use my mouse. So here is a string S, and it is hello world. It's looking very, very similar to what we did last time around when we had um, what are called C strings, character arrays. Okay, that's what we were dealing with the last time. So let's just take it a bit further. We're also going to have things like, hey, by the way, string, how long are you? Rather than you having to walk down your string, you can ask the string, hey, how long are you? We're going to also deal with cout statements. Cout statements are going to look exactly like we're going to work effectively like printf statements, but it looks in a bit more familiar way. You don't have that %d, %s, all this weird archaic way of writing the message. You have the word cout, and then you're going to put this is into the cout statement. Then you're going to put the very weird into the cout statement. Then you're going to put the number 4 into the cout statement, and then you're going to put a new line. That's end L is it for a new line. Hey, you're going to throw that in the cout statement. What you get in the end is this is very weird 4. Notice there's no space between the D and the 4. So this is very weird 4, and then a new line. For a lot of people, that's a lot more intuitive. And you'd say, why didn't we learn this in 1400? Well, what the heck is a cout? Is the question that I propose to you. What the heck does it mean? Why? What is it? Is it a magic? Is it magic? What is going on there? That's why we couldn't do couts before, because it acts like magic, and we may not want, we may not want magic in here. Let's see if I can get my pen. My pen's working again. Great. So here's a string. There we go. Got my pen again. Woohoo. Anyways, so what I end up having here is this is an object. This cout is an object that will take in, we have an operation for it, which will then take in some kind of data. And then it will, so when that's done, it will take, this will be another operation, which would put very weird at whatever cout is going to spit out. This whole thing is going to spit out. So that itself, from cout all the way to very weird, is one thing afterwards. It would be like saying 1 plus 2 plus 3 plus 4. That's really 1 plus 2, 3. And then I go 3 plus 3, 6. And then 6 plus 4, 10. Right? The answer ends up being 10, but it's this sort of nesting where we'll do the first operation, be done with it. Do the next operation with the first operation, with the resolution of the first operation. So this is the cout with this text message, done. And then I will do this cout with this text operation is done now, and I will now tack on this very weird, tack it on the right hand side. And then I'll tack on the 4, and then I'll tack on the new line. One after the other. Cout statements and cin statements are actually objects. And since we didn't cover objects, I didn't feel comfortable using them because they end up being like, magic. They're globally visible objects. So let's go to strings. This is what we did with string classes last time, right? Notice again, there is a difference between a C string and a character. A character looks like this. It is like the letter A, the letter Z, the character for the number 1, right? So I could also have something like this. That is not the number 1, that is the character representing 1. It has an ASCII value. Or you could also have tildes, for example, all sorts of different characters. We also talked about the fact that these characters are ASCII, and so that's essentially English-centric characters. Why? Because they were designed to prevent World War III, essentially. I told a story about that for BIT 1400. It was never designed for Mandarin. It was never designed for Japanese. It was never designed for any name a language, other language, right? It was designed for essentially Roman numerals predominantly, and English in particular, because it was for Americans and Russians to communicate with one another. So as a result, when we talk about this, it can represent characters, and those characters are representing some number between 0 and 255. They are exactly 1 byte. Okay, a C string is a bunch of those things. It is an array, just like we did arrays of integers. It's an array of characters. The important character at the end, though, is this. I really want to, I may not know how big this string I'm going to be dealing with is. It might be 15, it might be 40,000. So I need some really elegant way of saying, no, I'm done. I'm at the end of my string. And so the /0 is what we're going to use. It's actually, which is, by the way, exactly equivalent to the numeric value 0, or exactly equivalent to null. But we're going to use this /0 as a character to say, yeah, I'm done. When do I get to the end of my string? The end of my C string is when I get to a 0. Okay, that is what we were doing in 1400. We'd have these C strings, and then I might have functions such as strlen, and I'll put like CS in that string, and it's going to spit out a number, right? Uh, things like that, right? I'm going to make a new CS What it's going to do, the string length function is going to walk down the string and go, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 characters. I'm not including the 0 at the end. So CSLen would be the value 11. At position 11, I have the 0 character. Position 0, I have the H. And I have 11 characters in total. All right. Now I had all these different functions that I had available to me: strlen, strchr for finding a character in a string, strstr finding a string within a string. We had a whole lot of these functions, and you always had to pass in the string into the function to find out what you wanted to get out of it. What if the string knew about itself? What if the string could tell you, just instead of you doing the work yourself? So bad analogy, but it's just because I just went to my family's cottage with my kids, and I get out of the car and the kids run away, and then I'm going over there pulling out their luggage and bringing it into the house, and did you get this, and boys don't do this, and boys don't do that, and I'm asking the boys for things constantly. What I really want is the boys going and getting their own luggage and pulling it into the house, right? I want the individual thing that's being affected to actually control its own fate. I want my boys to bring in their own luggage. So instead of me doing all this work, and by the way, I'm bringing in something which is the boys' luggage. I want the boys to bring in their own luggage. So this is where, so by the way, this is what a character looks like. This is what a character string looks like. Notice the 0 at the end. It's a bunch of characters, one after the other, stored in an array. That's it. Notice it's also, it might be length 15. There are 15 spaces here, but the length of it is 11, because I will count up to here, I'll see the 0 and stop. Uh, here's me making a string, the same string, or effectively the same string. String str is hello world. Okay, it's going to look slightly different than you might have expected, but that's what you can do. I'm making a new object called string with the text hello world. And it's going to have the exact same thing as before. You don't have to worry about that part. And then a bunch of crap at the end. The bunch of crap at the end is the interesting part. Because those question marks, this stuff here, is all the functions, all the stuff, and all the hidden data I have associated with that string. So instead of me having to make a function and walk down and figure out the length of my string, it might be already stored in the data structure. Instead of finding something, I have a function built into the string, so it allows me to find a particular character. The functions and the data are wrapped together as one unit. So the string class is an abstract data type. It's actually not primitive at all. You would have to pull in the string header, right? I need to include string. They are programmer defined. Somebody else did it. They're not native to C and C++. You have to include this other library. But once I do, I can make a string object. So I'm making a string object here called movie title. The movie title is going to be Argo. I can also implement it this way. I can implement it this way. Another movie, Wag the Dog. Yes, this example is from well before. There's no point changing the titles for these things, but these are older examples compared to more modern movies. Right? I think this is actually from the textbook originally. Right? But they're two ways of making a string object. Fine. But here's the interesting thing. If I looked at the data itself, I will get this array with all the various things in there. there. I'll also get a capacity for the array. I will get the size of the array. I will get a bunch of other stuff with it. In fact, they're not just some of this hidden data in my array, like I have here, but I'll also get the functions themselves. And so an object is actually bigger and sort of beefier than just basic data types. Uh, there's more than just the contents. I have other attributes, the size, the capacity, but I also have the methods associated with it, all wrapped together. So I can do things like this. Movie title dot append, and I could just add a Z at the end of the movie title, and I'm done. I can find a particular character, or I can find a string in my movie title. So returns the first position where the X is located, and the X is also a string. It's found in the movie title. I think the X can be a character or it can be a string. I think they have both implementations of it. So I can find where the Z is in that movie title, or I can find where the word arg is in the movie title, and it will tell you the first position where that is found. I can say or beyond position X. So I'm going to find that's so. I'm backwards here. I'm thinking of str again. The movie title. I have a name for the movie. So let's say it's Argo again. The thing I'm looking for normally it is a string. So let's put the string R, and the position where I start. Sorry, I can't even read here. Let's say I'm going to start at position 2. So 0, 1, 2. Is the letter A and R anywhere from this position onward? No, it's not. In this case, it's going to return there is no there. It's going to say it's returning the first position. There is no position, and it should be a null pointer. It may not be a pointer. I think actually no, it's a position. It'll be an index, so it'll return -1 in this case. And if I just set a position 0, it's going to return the value 0. It's going to be the very beginning of the string. I can get the length of the string, movie title length. In this case, it would be 1, 2, 3, 4. It'll be the value 4. I can replace all instances of x with n in the replaces n characters, the number of characters in the movie title, beginning of position x with whatever this string is. Every single time. Honest to God, in case you're wondering why I don't remember all this, because I don't remember all of this. I don't memorize it. We'll see when I code some of this. I'm just going to let the IDE, I'm going to let Visual Studio do all the heavy lifting for me. It's going to remember everything for me. That's the other huge benefit for anyone that has memory of a goldfish like I have. I don't have to remember the name of these functions. I don't have to remember str, and all this crap. I just I have a string, I put a dot, and it's going to give me my options. I can go looking around to see what options I have available to me. Okay. This normally happens with a period at the end, much like what we had with structs. Remember, with a struct, if I wanted to get some subpart of the struct, like the next element in my linked list, for example, I put a dot. Or if it's a pointer, I put an arrow. Well, it's the same thing for my function call, not just elements, sub-elements, or attributes of a structure. For an object, I use a dot to say, yeah, and get me that function associated with that object. So here is, I've got a movie 1 with not initialized to anything. I got another movie called initialized to Wag the Dog. I'm going to have another movie. I'm going to initialize it to be Wag the Dog as well. It's a copy constructor, which we're going to get to constructors in a second, or in a couple weeks maybe. It's just going to say whatever this is, make it the same. I can make a new movie with this as the starting point and initialize with the first 5 characters of the movie. I've never once used this one, right? I could say I'm going to make a movie with all W's. I'm going to have 10 W's in this case. There's a million and one ways of doing this. You just sort of look it up as you go. I may have a movie based on this movie with, let me see here, with the substring of it's 7 characters long and it's starting at position 0. There's so many different ways you can start up a string. It's fine. You look it up when you need it. But the fact that they're automatically wrapped up with your string means you don't have to remember how to do it. You just look it up when you need it. I can even do weird things like this. I can do, so I have my cout statement. Let's do this. This will be one thing. I'll have a movie title, Argo, plus, and then a space, plus, and the other movie, which is Wag the Dog. So it would be Argo and Wag the Dog, end line. I have a third movie named Argo. We're going to start that one. If this movie title here, the original movie title, which I haven't changed, is equal to this movie title, they are identical movies. I would assume that this thing, Argo, so I think this thing is going to say Argo space Wag the Dog, new line, and then it's going to say identical movies. The movie title has not changed between this position here and here. This cout statement is just going to say Argo space Wag the Dog, and then it's going to say identical movies because the first movie here, Argo, and this movie, Argo, are the same thing. We can also do things like this. We can get the length of Wag the Dog, 11, right? We could do, so another movie, where's another movie? It's Wag the Dog and Wag are, and we're going to compare Wag with another movie, which is Wag the Dog, uh, and we'll see if they're identical or not. So are Wag and Wag the Dog identical? Are not identical. Wag and Wag the Dog are not identical, obviously. No, the first 3 letters are, but one is a lot longer than the other. We can do another movie and Wag starting at position 0 for 3 characters. So we can do a comparison starting at position 0, only 3 characters, and this is only 3 characters. This should be now identical. The first 3 characters are the same between Wag the Dog up here and Wag down here. Those two things are identical to one another, right? So I would expect to say identical now. Are identical. Nice. There's Here are a bunch of other operations. We can insert, we can erase, we can replace, we can swap, we can get allocated, we can find a particular thing, we can copy our constructor, we can get the capacity, how big the array is underneath it versus how long the text is. We can resize the whole thing. We can do all sorts of things and just look it up. Right? Honestly, I don't remember. It just slips out of my head. It'll probably slip out of your head too. Just look it up. That's why we do objects. So here would be another example. We can even do string comparisons, which we couldn't do before. Last time we had strcmp before, which is string comparison, right? Now we can just say greater than or less than or equal to or not equal, right? Here is Mary, here is Mark. Is Mary greater than Mark? Well, that's true. Why? Because the Y comes after the K. Well, let's just make sure that this is in fact the case. Okay. So the Y comes after the K, so the Mark would be first if you ordered them sequentially. Is it less than or equal to name 2? No. Mary comes after, Y comes after K in alphabetical order for sorting it like, how we sort things. We sort text. It's not Mary does not come before Mark. Are they not the same? Correct, they're not the same. So not equal to one another. Mary and Mark are not the same, therefore Mary is not equal to Mark. Can we say that Mary is less than Mary Jane? That is actually true. It is a slightly longer text message, and therefore Mary Jane comes after Mary alphabetically. It's how that's not computer science at all. That's library sciences or how you sort things, right? This is just how you would sort text, the standard approach with capitalization and lowercase, and how you figure out the order of things. That's going to be how you normally assume things get sorted, right? And now I can do greater than, less than, or equal to, not equal to, equal, all the usual things like a mathematical operation, but with strings. I couldn't do that before. Before, I needed to do something like this. strcmp string comparison, and it's either going to give me a negative value if if the first parameter comes first. It's going to give me a positive value if this parameter comes second, if this thing is later, if you will, or 0 if they exactly match, right? So strcmp before we had to worry about is it before, is it at, that we get either a negative value, a positive value, or 0. Now we can just say, is it equal to, is it not equal to? We can just do direct comparisons. So we can say, is the part number exactly equal to this thing? Before we would have to say, is it that string compare equal, does it return the value 0? Now we just say, are these two equal? Are these two equal? Otherwise, spit out something else. We can do the same kind of operations that we did with inserting into a string. We can insert a string into a stream for standard I/O. We can CN can go input something into a string. We can assign values to our strings or assign strings. This will append strings to the right hand side of something. We can concatenate two strings. So I have string 1 plus string 2. That'll give me a brand new string with string 1 plus, string 1 and string 2 attached together. We can get the individual characters for the string, the same way we do elements in an array. We're using the square parentheses. And we can do this greater than equal to sign. That's these normal mathematical signs. So I'm going to do one more example, then we're going to code something up and see how things work. And we're going to look at a C string and we're going to look at a normal string. Okay, so here's word 1 and phrase 1. They're two strings. Word 2 is going to be equal to dog. We're going to take user input for word 1. Word 1 doesn't have anything in it. We will get user input and stick it into word 1. So the user, I'm going to say, is going to write the word hot tamale. Why? Because they do in this example. They're going to type hot tamale. It will only take the hot. Why? Because CN goes to, the special thing about CN is it goes to whatever white space. If I have a white space, it stops putting it into the next thing. If I had CN word 1, double arrow word 2 or word 3, I get tamale for the second for the next field. We can look at that in a bit more detail. Okay. I have a string called phrase. It's going to be equal to word 1 plus word 2. This will give me hot dog, right? The hot is included, let me see here. No, the dog, notice the space in front of the word 2's dog. So this is word 2, this is word 1, and when I concatenate them, when I do a plus, I stick them together. That's concatenation. I can now add on a bun at the end of this. So I get hot dog on a bun. I could just do a cout statement for the whole thing. So cout phrase, and it would be hot dog on a bun. I could do a for loop and say, oh, by the way, I'm going to go through this. Let's even get rid of this and say less than. Come on. I think my pen's about to die on me here. I don't know why the pen's not working. String phrase dot length. I don't know why my pen's not working right now. Oh yeah, pen's not working at all right now. Okay. Phrase dot length instead of the 16. If I put phrase dot length with curly parentheses afterwards, it's going to get, it would be the same thing as putting the number 16 in here, and it would still print out hot dog on a bun, character by character, printing out one character at a time. Okay. We can also read in, sorry, I want to do a couple more. We can also read in a full string, a full line of text. So before we used to use we can get a line from a text file. We used to use fgetS or getS for getting in an entire string. We can do similar things with CN. So I can say get line. I'd pass in, if I use the function get line, I'd pass in the CN statement, my input, the way I get my input, or a file reader that I'm going to be using, the way I get the thing I'm going to stream information from. So it's either a file reader, like, or it is the CN statement. And where it's going to go afterwards, my string. I'm going to put whatever the user types in up until a new line is typed, at the end of a new line is typed from CN, and I'm going to stuff all of this into a new variable called my string. Okay, because CN only stops when you hit any white space, getLine will keep going until you get to a new line, a carriage return. And so it will be a slightly different beast. So please enter your name. I could get the entire line and it would be, David Sprague. Two different words, all the full name would be in here. Not just David, but David Sprague. You can also then enter the city you live in, and I could get the full line, St. John's, Newfoundland. The whole thing could be in there instead of just St. John's. But St. John's also, if you put a space between St. and John's, which you should, it would not be fitting in. If normal CN wouldn't work for me there. I need to put an entire line in. I need to use getLine for anyone with city names with multiple parts, like St. Cloud. So CN, the getLine function is extremely useful for getting more than just up into the white space, and it's a nice workaround. We'll be looking at that in the assignments coming up next. It's one of these short assignments for assignment 2. Okay, we're going to get back to objects in a second, but I'm going to take a pause for right now. When I come back, we're going to do a bunch of examples for strings just to see it in action, and then we're going to get to objects themselves. Okay, so let's stop the video now.